The given equation here is another non-homogeneous higher order equation. And similar to the previous video, our g of x here is constant, specifically 10. So we have structured already the process in solving for equations like this. But we are going to use this again the same general solution, because this is not the same as the homogeneous equations we have before, where we simply take the auxiliary equation equivalent of this equation and then solve for whatever with the roots, whether they are distinct and real, or whether they are repeated and real, or we could have imaginary, because we have different forms of general solution. Here, the solution for this non-homogeneous higher order equation is y is equal to, it's y, okay? Just don't forget that it's y, because that's the dependent variable here. Y is equal to y sub c plus y sub p. Y sub c is what we call as a complementary solution if we are going to treat this as our g of x equal to 0. Okay, so that's the same process that we did before. The only change here is we will be adding y sub p, because this is not 0. We have another method for that. Y sub p is called as a particular solution, and please refer to this table here. This table shows us the form of y sub p we need to follow, and since our g of x is a constant, we're going to use here y sub p equal to a. And later we will be dealing with that as a second part of our process, because we need to get the exact value of a to be added on our y sub c for our general solution of this given equation. So first, let's solve for y sub c. As mentioned, we will be treating this equation b equal to g of x, which is 0. With this, we could construct an equation with differential operator d, and it would be in this manner: d squared. You will have here plus 2. Then you have y equal to 0. Take note that we don't have d here because this is just 2y. So we'll have that. Okay? And then for our auxiliary equation, you will get m squared plus 2 is equal to 0. So let's solve for the roots of this given auxiliary equation. You can actually move 2 on the other side. You will have m squared is equal to negative 2. Then, when you take the root of both sides, you will get plus minus square root of negative 2. Okay. With this, our m here, we write this is plus minus square root of negative 1 and square root of 2. So our roots are actually imaginary. You have plus minus square root of 2i. Take note, you need to go back to the general solution when we have roots being imaginary. And this is not repeated, we only have this set. So in the form of a plus minus bi, our a here is equal to 0 as we don't have the coefficient here. And our b is equal to square root of 2. We need this because the general solution for homogeneous equations where our roots are imaginary follows this process: e to the power of ax. The a is presented here times c sub 1 cosine of bx. The b is this value plus c sub 2 sine of bx. Okay, so plugging that in here, our y sub c is e to the power of 0x times c sub 1 cosine of square root of 2x plus c sub 2 sine of square root of 2x. Since this is just equal to 1, our y sub c is equal to c sub 1 cosine of square root of 2x plus c sub 2 sine of square root of 2x. This is just y sub c. We need to look for y sub p first to complete our solution here. So let's use this as indicated in our table earlier. Our y sub p is equal to a, but we need to get the actual value of a. You can do this by deriving this y sub p matching to the highest degree of our equation here. It's second degree, so we'll end up until the second order derivative. The first order derivative of y sub p, being a as constant, is 0, and that also automatically means that the second order derivative is also 0. This will be used later on because our equation of y double prime plus 2y equals to 10, we will be substituting y double prime of p here and our y sub p to our y value here. Okay, so it would be like this. So following this method, you have y double prime of p instead of this one here plus 2 times your y sub p for your 2y. So 2a is equal to 10. Okay, or let's have it later. So you could have, again, you will have this one. 2y is y sub p is equal to 10. Then we substitute the values. That's 0 plus 2. Your y sub p is a is equal to 0. Hence, 2a is equal to 10, and a is actually equal to 5. And what is a? This is actually our y sub p presented here. Hence, y sub p is just equal to 5 as well. Now that we have y sub p, we already had y sub c here. Using this general solution of the equation, we can now structure this solution here. Y is equal to y sub c plus y sub b. So y is equal to your y sub c here. C sub 1 cosine of square root of 2x plus c sub 2 sine of square root of 2x plus your y sub b, which is indicated as 5. This is now the solution of the given non-homogeneous equation. Again, this is a combination of y sub b following this method and y sub c following the usual method of solving homogeneous equation where g of x is expected to be equal to 0. So from this, we'll have this as our solution. Thank you very much for watching.